Hello guys, so welcome back to my channel, and in today's video we're going to be looking at C programming. So this is what you have been waiting for, and I'm sure you've heard a lot about C programming and you're already scared. The only thing I'm going to tell you is that yes, C programming is not as easy as any other programming language. But if you put in your best, if you follow the tutorials I'm going to be giving you here, you are going to scale through C programming, not just because you want to do tasks for ALS, but you will end up knowing C programming as a software developer or as a software engineer, and you will thank yourself. First, you need to know the basis. And in today's video, I will be taking you through the basis of C programming, such that you don't make such mistakes that are going to be very costly in the long run. So you need to pay attention. You need to follow the video. Every second of this video matters a lot in your journey as a C programmer. C programming, like we all know, is a low-level language. And if we say C programming is a low-level language, it means that it is very close to machine language, which is the hardware, the computer hardware. C programming was created by Daniel Ritchie in 1972, and I'm sure most of us were not born there, in 1972. And in C programming, you are going to be needing a compiler. So it's a compiled language and it's not object oriented. All right. So C programming is a successor of the B programming language. Now, what do you need to start your C programming? Number one, you need a terminal, which you already have: your SANDBOX, your Ubuntu, your share. It's a terminal. Number two, you need to know the command language commands. Okay, the command language like ls, pwd, ls-l, cd, mkdir, arrow. You need to know those languages, those commands. And then you will need a compiler. For this particular C programming, the standard we're going to be using is going to be the GNU, which is GCC command for compiling your language. All right. So that being said, I'm going to be working with the terminal, and then I'll be showing you some stuff about C programming. Now, the next thing I want you to know is that when you are writing your C program must end with the extension .c. For instance, if we're going to create a file for a C program, if we say touch, to create a file, we're going to say hello, and it must end with a .c for the terminal to know that this is a C program. If you don't end with .c, it will not be recognized as a C program. So you must make sure that whenever you are creating a file for your C programming, it must end with the extension .c. Okay, very important and very key. So let's create this file, hello.c, enter. So now we have succeeded in creating our file, our first C programming file, which is .c. Okay, now the first line of your C program must start with the #include stdio.h. So let's open our file in using the VI editor. So vi hello.c. All right, so here we are in our code editor. Now your first line in C programming must start with the header file. And the header file, the standard header file is #include space stdio.h. All right. So this is your header file. It must start with your header file. Your first line must start with the header file. And then you also need to have comments. Now, by the time you start doing your task, you're going to start seeing Betty. So Betty style is just to help you write your code in a way that is very readable, to be in a standard format. And because of that, for each task you are going to be doing, you will add a comment. And to write a comment in C programming, just after your header file, you are going to write a comment. And this is the style to write comment in C programming. So a / and then your double asterisk for multiple line comments. So for each comment, you're going to have an asterisk space. So let's say we are given an asterisk for the main function. We're going to say main hyphen space. This is a function in C. Let me stop there. So now let's also write this. We're going to say return, just exactly the way it is for the Betty style, space, always 0, enter, and then you close your comment with an asterisk and then a /. So anything you write in between the / double asterisk and then asterisk and the / is considered a comment. All right, so that is how to write multi-line comments in C programming. Let's move on. Your next thing you must write in your C programming is the main function of your program. And without the main function, your code will not compile. Like we know, C programming is a compiled language. So the main function is always int main void. So this is the main function in your C programming, int main. So int stands for integer, and then so this is the main function, and it's returning void. So there is no function inside the main function. So if we have any function, then it will not be void. We're going to include the function there. All right, so the function is void for now. So that is your standard function, main function. And just after that, what will precede that will be your curly braces. To start your program, you must have the curly braces. So every code you're going to be writing will be in between the opening and the closing curly braces in the main function. Please, this is very important. So anytime you make a mistake of not adding curly braces in your code, you're going to see errors. So just after your main function, open your curly braces and then close it. So your code is going to be in between the opening and the closing curly braces tag. All right. Now, the next thing the last thing you will have in your C program is going to be what it will return. So here we are returning 0, okay? And then each line of your C program must end with a semicolon. So these are standards in C programming. So this is how you can structure your C program, and every other thing will come in between all this. So your code is going to be here. All right. So like I said, you have the header file, which is a #include stdio.h. You have your comment, and this comment follows the Betty style, which you will learn soon. We have your main function, and then just after your main function, you have the opening curly braces, and then you have your code inside here, and then at the end, you're going to have your return, and then your closing curly braces. And then, like I say, your code should end with a semicolon. Okay, now let's go on. So this is the basis. This is how to start your C programming. This might look very strange for now, but with time you're going to get used to this and it will be at the tip of your finger. Now let us look at writing a very simple program in our C programming. We are just going to write a simple program and then we're just going to say printf. I mentioned this in our last video, printf, sorry. So it's going to be here. All our program is going to be here. So I mentioned this in our last. So printf, I will open my bracket without a space and then the double quote because I am going to write a string. All right, so a string is an array of characters. So I'm going to write hello world. Okay, now because it's printf is formatted, I'm going to add a \n in order to give us print this in a new line, and I will close my code and then close it, and then followed by what? A semicolon. So like I say, your C programming, each line should end with a semicolon. So every code we've written here, what we are asking for is that print for us hello world followed by a new line. So let's save and exit. And in C programming, you cannot just come and say and echo hello world. Because it's a compiled language, you need to compile your code. All right. So we can compile our code by saying gcc followed by the name of the file hello.c, and then we can use this flag which is -o to output this file to another file that we can just call maybe hello. So what this will do is that instead of printing the results, by the time we call this on the screen for us, it will output the result that it will compile using the -o into hello. But let's leave it at that for now. Let's just compile our program and see the default. Now before I compile, let me show us something. So if I do ls before I compile, I'm going to remove a file called a.out. So rum-arrow a.out. Okay, so let me ls again. So a.out is cleared. So let me clear the screen. Now, by default, if you don't output your C program, so if you don't do, let's say gcc hello.c, and then you output it with -o into another file. So let's say we call this file hello. If you don't output it and give the file a name, by default, C program is going to create a file for you and I'll put that result there for you after compiling it, called a.out. So by default, it will impute your result, your compiled result, into a.out. So this is what I mean. Let's do gcc hello.c and enter. So now it has compiled. If we have errors in our program, it will not compile. It's going to give you errors. All right. Now, if I do ls again, you're going to see that the file a.out has been created for us. So you see now we have a.out again, which is where our compiled code is right now. So how do we access this, our compiled code? We're going to use // the name of the file, which is a.out, in order to view the content of our compiled hello.c file program. So enter and you see hello world. Okay. So like I said, by default, if you do not give the program what the name of the file is going to be, it's going to create a file for you called a.out. Now let's do something. So let's say gcc hello hello.c, and then we'll output it to hello and enter. If we call on hello now, we're going to have our file, our content inside hello. So if we say /hello and enter, it's going to print out hello world for us. So the -o help you to output the result into a specific file that you want, and this is already a compiled file. Now in C programming, we have 4 basic compilation stages. 4 basic compilation stages. The first stage is the preprocessor. And in the preprocessor, our file flag for compiling is GCC-E. GCC-E. So if I do GCC-E and I say hello.c and enter, so you see, so this is not what our computer has run into problem, because we cannot even understand this language. So all this is just a file we write, hello world. So you can see that this is not what we understand, because is preprocessed. All right, so we cannot understand what it's saying. If we say GCC, so the next stage after the preprocessor is the compiler, and the compiler will use the flag GCC-S. So if I say hello.c, is going to compile this into a compiled a compiler, which is the flag -s. Okay, and then it's still not what we can read. So if I tap enter and then we run our code, so if I say a.out hello world, okay, so let's see. GCC-C, small c. So this is the assembler. So like I say, we have 4. Let me clear my screen. We have 4 compilation stages. Number 1 is the preprocessor, and is denoted by GCC-E. Number 2 is the compiler, which is the compiling stage, and is denoted by the flag -S, and then GCC-c, which is the assembler, and is denoted by GCC-C, and then the last stage is the linker, which is the linking stage, is denoted by GCC-O, which is the one we use, which is the one we understand. All right. So at each phase of this compilation, the machine, the program is rolling this in order that the machine will understand whatever code we put here. So we have 4 compilation stages in C programming. The first one is the preprocessor, denoted by the flag -E. The second is a compiler, which is denoted by S. And the third is the assembly, which compiles the code and then is -C. And we have the final stage, which is the linking stage, or the linker, denoted by -O. So these are the four compilation stages of C programming. These are the 4 compilation stages of C programming. All right. Now the next thing I want us to know is how to declare variables in C. How to declare variables in C. Now let's open our file, vi hello.c, and enter. So how do you declare variables in C? Like I say, this is constant, so we are not removing it. So I'm just going to remove this, but every other thing is constant in C programming. So if I omit, let's say I omit this curly braces, the last one, and then I save this code and try to execute this code. So if I do gcc hello.c to compile this, see what it's going to give us. It's going to give us error. All right, it's going to give us error. It said there's expected declaration or statement at end of input. All right, so it shows us even the line in line 11. So for us to avoid the error, we must always include our curly braces at the end of our code. All right, very important. Okay, so now we're going to declare a variable in C. How do you declare a variable? So let's say int I with a semicolon, and then we initialize the value by saying I is equals to, let's say, 20 with semicolon. So what does this mean? We have declared a variable called I, and we're assigning 20 to I. All right, so we're saying that I now is equals to 20. So that is how to declare a variable in C and then initialize your variable in C. So you can also declare and initialize at the same time. So we can say something like int y equals to 20. So rather than using two lines, you can use just one line to declare and initialize in C programming, and the both of them are quite correct. So you can say int I, and then you move to the next line and say I equals to 20 by assigning it or initializing it. Or you can just say int y equals to 20, and then it still works. So that's like declaring and initializing or assigning it to a particular value. All right, so that is how to declare and initialize in C programming. Okay, so the next thing I want us to know is declaration of different variables in C programming. So we have the int, we have the float. Sorry, let me make sure this is in the same line. The float, we have the char, and then we have the string, which is also represented by char. Yep, the string. Okay, so let me explain this. Of course, we have double, which also represents float, double. All right, which also represents float. So I don't really use double. So we have the int. Now the int here represents integer. So for int, it takes numbers without decimals. Okay, that's int, integer. So it takes only numbers. So if you want to declare a variable in C programming using the int, you just say int and then you give the variable a name. So you can declare a name for the variable. For instance, we say int and then we say int num. Okay, int num, and we can say equals to, let's say equals to 21 with a semicolon. So this is declaring a variable and then initializing the variable at the same time. Now for float are numbers that have decimal points, decimal places. So for float, we can say something like CGPA, right? And we say is equal to, let's say, 4.550, something like that. So that is what a float represents. So a float represents numbers that have decimals. All right, numbers that have decimals. Then a char, like it's pronounced, is a character. So a char can take only one character, just one character. For instance, you can say char, and then you give it a character. Let's say you can say char, maybe grade equals to, you can say A, capital A. All right. Now, if you can see, each of these will always end with a semicolon. Don't forget. Now, you can say that for the integer and the float, there is no quote between them, but for the character, there's a quote in between them. So you always have quotes in between your characters in C programming. But the integers, you don't need to put them in quotes. All right, so that's another hack. You don't need to put them in quotes. But for characters, you must always put them in quotes. The next thing is the string. So a string is a combination of characters. So we can say a string and we'll give it a name. So let's say string school. And then we can give it a name by saying the name of the school is ALS. So we can put it in quotes, single or double quote, and say ALS, and with a semicolon. Okay, so these are the various variables you can use in C programming. There are more, but these are the basic ones that you will be using. The integer, which represents a whole number, the float, which represents a number with decimal places, the char, which takes only one character, and then the char with the square bracket, which takes in more than one character. Now, in this square bracket, you can declare and say, okay, I want just 20 characters in this. So meaning anything above 20 characters cannot go into this string. So if you put in a particular number inside or in between the square bracket, it's going to be maximum of that number. It can be less than that number, but it cannot go above that number you put. So for instance, if you are putting any text that is more than 20 characters, then it will only pick 20 characters and leave the rest of the text to you. So by putting a number, by defining a number inside here, inside the square bracket, you are telling the program, do not print more than a particular number of characters. All right, do not print more than a particular number of characters. Now let's move on. The next thing I want us to know is a format specifier in C programming. All right, so for each of these variables we have declared, the int, the float, the char, and the string, they have format specifiers. What do I mean by format specifier? So if you are going to do concatenate in C programming, you are going to be needing your format specifiers in order to work with it. Now, this is what it is. Let's write something and I will explain what I mean after now. So let's write a simple program and just say printf, and with my double quote, I'm going to say the name of my school is. The name of my school is. I'm going to use a format specifier now and say %s. The name of my school is %s. I'll close this and then I'll write here school, okay? And close this, followed by a semicolon, okay? So let me put a new line here. Let me put a new line here, /n. Okay, so the name of my school is %s. Now, what we gave to school is ALS. So if I save and exit now. Let's compile our program and see. Okay, there's an error. Multi-character constant. Okay, let me see what that means. Let me see what that means. So the name of my school is correct. The name of my school is, okay. Let me remove that for now. And let's just change our sentence. And we're just going to say something like, I just want to show something. We're going to be writing a program very soon. We want to show something using the printf and the format specifier. So let's say, instead of using this, I'm just going to use, let me use name. In the string, I'll use name here. Okay, and then I'll pass in my name here. So let me pass in my name here and say equals to double quote Sunday and close, followed by a semicolon. Okay, so let's write our program and see now. So I'm going to say my name is, okay, my name is, I will say percentage S. My name is percentage S. I'll close it, comma, and then my name. I'll say name here. Close and enter. So let's save and exit. And let's compile. Okay. So now my name is, now if I run this code, which is /a.out, that's the default, it's going to say my name is Sunday. My name is Sunday. So the percentage S, which we use, pick our format specifier for a string. Format specifier for a string, which is this S, Sunday. So I declared my my string as Sunday, and then the string name is name. So that is why I called name here. So if the string name was to be something else, I would have called that thing here, and it will answer us with the format specifier, which is S for name. So my name is the format specifier Sunday. All right. Now, just so we don't get confused, let me show us something. So like I say, each variable in C have a format specifier. So for the int, the format specifier is %D. For the float, format specifier is F. For the character, the format specifier is C. And then for string, format specifier is S. So %D for integer, %F for float, %C for character, and %S for string. Now, if you interchange this format specifier, it will not work. For instance, instead of using the percentage S here, if we use %D, see what is going to happen. %D, and then we are calling name instead of calling num, which is the name of %D. This is what is going to happen. So if we do GCC, see what is going to happen. It's going to give us error, telling us that %D is not what you're supposed to call. You're supposed to call %S. Okay, so let's clear our terminal. So that is format specifier in C programming. So you can use that to write your different programs using your format specifier. Let's go to our file again. So here we can write something like, let me clear all this. So we can write something like, so I'm going to clear all this. We can write something now like, so we declare and say int age equals to, let's say 50, and say child name, is equals to, let's say Emmanuel. Okay, so we have declared and initialized two variables here. Int age equals to 50, child name equals to Emmanuel. Now we want to write a program that will print this for us. So we're going to say printf. We open our bracket and a double quote, and I will say my name is, so my name is percentage s for a string. I am percentage d for the integer. I am this years old. All right, I'm just going to do a new line character. So comma, I'm going to pick the names of our variables now. So we start with, my name is percentage s, which is percentage s, the name is name, so I'm going to write here a name. Okay, and then I'm going to write the next variable, which is age, saying we are picking the name of the next variable. All right, and I will close my bracket here. Okay, so let's see if this file will compile. So let's compile and see if it will compile. All right, so it has compiled. So let's check our file, a.out, and enter. So you see my name is Emmanuel. I am 50 years old. So let's cut hello.c and see. So what we wrote was, so my name is Emmanuel, I am 50 years old. What we wrote was, my name is percentage s. So he picks percentage s, is so percentage s is the character, which is name, Emmanuel. So my name is percentage s, which is my name is Emmanuel. I am percentage d, which is an integer, and percentage d is 50. So I am 50 years old. Then the /n is the new line. And then we'll now pick the names of the variable. So for percentage s, which is in the same order, percentage s is name, percentage d is 50, which is age. So I cannot interchange this by saying my name is percentage s, I am percentage d, and then I will interchange the name and say my name is percentage s and I put age first. It's not going to recognize it because percentage s is not for age. Percentage s is for name, which is the name of the value that is inside, and then the value that is inside name is Emmanuel. So if I want to pick percentage s, I will say my name is percentage s, and then name has to come first before age, because age comes after name, which is percentage d. I don't know if that is clear enough. So if I interchange name and age, it's going to give us error because the program will look for age, name, and what it will be seeing will be age. So it's going to give us error. It won't compile. All right. So that is how you can use your format specifiers in C programming. All right, so as we go ahead with this program, I am going to be introducing us to more programming languages, more commands that are going to be very handy for us to use. All right. Now, the last thing I want to show us in this tutorial for today is going to be, I'm going to show us how to use the scanf. Or before the scanf, there is something called size of. All right, so we have these variables, the integer, float, character, string. They have different sizes, which we have done a particular quiz, should I call it quiz, evaluation that they were asking us for size of int, size of char, size of float, and all that. And this question is also going to come with our next task that we're going to be doing, which is HELLO.C. Now, if we want to know the size of a particular, the byte that is carrying in a particular system, either a 32-bit system or 64-bit system, we're going to use this command for each of these variables, either a float, a character, or an int. All right. Now, how do you do that? We're just going to say, let's vi to our file again, hello.c. So here, I will just write it down here. All right. So we're going to say printf. So I'm going to print size of an int. So I will say size of, like I said, this question is going to come in our next task, size of, and then I'm going to give it percentage, because it's an integer, I'm going to give it percentage %d. All right, size of this, and I'm going to give the command which is size of. So this is a command in C programming. Size of, and then I'll open a bracket, and I will say float. So I want to know the size of float in my system is 64-bit. Size of float in 64-bit system. There is a challenge. What? Okay, I've seen it. So quotes here, yes. And then maybe I should add a new line, /n. Okay, so size of float in 64-bit system. Let's also do printf for character. So I'm going to say size of char. So size of char followed by a new line. Let me add a new line there. Okay, so I'm going to say size of, open a bracket, and I will say char in 64-bit system. The last one, I will do printf. I'll open my bracket, and I will say size of integer. So size of integer, let's have a new line, and I will say size of, which is a command. I'll say int, and I'll close and do this. Okay, so let's check our code and see what the size of float in a 64-bit is, char and integer. Of course, float, character is always 1, and then integer is 4, but let's just see. So escape, save, and exit. So let's see if our code will compile first. If there's error, it won't compile. Okay, it has compiled, and then let's run our code. So you can see size of int is 4, size of character is 1, size of one is supposed to be float, one is supposed to be int. Let me see. That was typo error from my end. Okay, so this is supposed to be size of float, because this is float. All right, so we can just say change that. Of course, but you've seen how it is. So size of float is 4 in 34-bit computer, in case you are asked anytime, any day. So let's compile our code, you must always compile your code in C before you can see the output. So you see size of float, size of char, and size of int. Okay, now, just before we go, the last thing I want to show us is how to use the scanf and printf in your C programming. Now, the scanf helps you to impute. So you can ask a user to impute something into the C programming, and then you print out whatever the user imputes, okay? So let's see how that works. You are still going to use our file. So let me just create a space that we'll use. I'm sure this is becoming interesting. You are going to enjoy C programming if you put down your head to learn. Okay. So what I am going to do now is I'm going to initialize a variable. So let me just initialize here and say int. Or let me just do this. So I'm just going to say I'll give it a name, so char name. So you can use anything. This is not default. I just love using name. Okay, so this is a string I've declared here. Okay, and then I'm going to ask for an input. So printf. So I'm going to ask for an input with my printf. So I will just say, what is your name? Or enter your name or whatever. Okay, so let me add a new line character, /n, and I will close this. So I'll just ask what is your name, and then I will use the scanf to collect that user input. So scanf will help you to collect user input. So what is your name? Scanf, name is a string. So that means it's going to be percentage, you guessed right, S. So name is a string, so it's going to be percentage S. And then I will close this, comma. What is the name is name. That is what we have there, name. All right. So so this is saying that what is your name? Scanf will collect the input of what is your name. So let's add a semicolon, and then I will print whatever the output is using printf again. I will say printf, and I will say my name is, let me add this. So I'm going to say percentage S. So my name is, let me add a new line, and I will say name. I'll close this. So my name is name. Okay, so let's compile this and see what we are going to have. I hope this is entering. I just hope it's entering. So let's compile and see if there are no errors. Okay, so there's an error. Let's see the error. Line 17, no linkage. Okay, let's see. Do we have name here before? Okay, yes, we have name there before. So let me just remove this. So let's use the previous name we declared. So it's the same thing, provided it is in the same function, it's the same thing. All right, so printf, what is your name? Scanf. So this is the name now. Okay, I see where the error is coming from. So let me remove this. Yeah, because we are not supposed to define the name. You need to add your name. Okay. So let's declare this again. We're going to say char name. Okay, so this should work. So let's compile again. GCC HELLO.C. We have same error. My name is, Okay. This is for the program above because I removed the Emmanuel. Let's clear that. So let's just remove the code so that we don't have these errors. Let's remove the code above. So because I removed the declaration of Emmanuel, he's not seeing from our program above, he's not seeing that Emmanuel again, which is this one. So let's remove that. So I'm just going to clear the program from here. Of course, we've seen what this can do already. All right. I'm sure this is becoming interesting. It might look a bit strange, but if you watch this tutorial over and over again, you should understand what we are doing here. So this should work. Let's see again. And let me clear my terminal. Oh, clear. Great. So GCC, let's compile and see. My race size missing a name. Oh, okay, we didn't give it a size. I thought that should have worked without the size. So let's give it a size so that just for security reasons you don't enter. So let's just say 50 characters in the array. So let's compile again. All right. So let's run our code a.out and enter. So it's going to ask you what is your name. So I will just say, let me say Francis and enter. So you say your name, my name is Francis. So if I run this code again, it asks me what is my name. Whatever input I give to it is what is going to print out to me. So if I say Emmanuel and enter, it's going to say your name is Emmanuel. All right, so this is how to get user input in C programming. All right, guys, so we've come to the end of this tutorial. I am going to do another video for us, for the main task. But for now, enjoy this tutorial, and I'm going to put a link in the description of this video for the answers to all our tasks. But if you want to learn while I solve the task, then you want to also watch the next tutorial video I am going to post solving the task and checking, starting from creating a repository to cloning it in our terminal, because this is a new phase we are entering. So we're going to have a new repository, we're going to have a new, we're going to clone again, but you don't need to do the git init global username and pass and email again, because you already did that in your terminal. All right, so thank you for watching. Leave a thumbs up, leave a comment if you learned something from this video. See you again in the next video. Stay blessed.